I'm going to demonstrate the usage of a secret plus tuple. So a tuple is a container. It's able to store any amount of different types. So you can see that here I've selected a variety of different types it's able to store, including a reference. So when we want to print these values, first of all you can see it's a bit clunky to do so. We use the standard get function, which takes the size type as a template argument, and it is called with the tuple. So the reason this is because C++ needs to know the actual type of data we're dealing with at compile time. So by putting in the integer that it will use, or the index it will use at compile time, it's able to know the type. Let's run this code and see what happens. So you can see that it does in fact print each element, and then below, so I'll show you how to do it in a minute. So you can see how we're going to actually print the tuple in the next file. I'm going to click in here, so we have our print tuple, and this is there are many ways of doing it, so this is our first way of doing it. First of all, we need to declare this first, because we actually, this is the recursive function. We need to give it a size type, and that is the index that we're currently looking at within the tuple, and then we have the types that the tuple contains. And if we get to a different overload, because every single tuple essentially is a different type depending on the types entered into its template arguments. So first of all, obviously we print the opening curly brace if it's the start. Next, we print the closing brace if it were at the end. Then otherwise, what we do is we get the current index. So for example, start at 0, so we'll do standard get 0 for example, and then we'll call the same function, except this time we'll get the next index. And so we repeat this, and the function will stop recursing once it gets to the end. So we'll have a look in our print tuple2.cpp. This one here works a bit differently. This uses an index sequence. So an index sequence is a compile time sequence of indices. So it is specifically an integer sequence with the type standard size t. We start off by entering the types, essentially a consecutive sequence of integers starting from 0. So we don't actually need to assign a name to it. All we need to know is the i's, that's the important bit. What we do is we go through each element, and we, obviously the first bit's about printing it common, that's not too important, and then we can imagine i's in this context being the current element when it's expanded using this strange syntax. So in order to call this function without requiring a third argument, which is the standard index sequence, we're going to wrap that function within the printing overload. You can see here that we're just going to use a make index sequence and just chuck a index sequence using the size of the tuple. This is done by using the size of dot operator on the types of the tuple, and that's one way of finding the size. So for our third method in this, we're going to use a standard apply function, which acts kind of like a for loop in this case. So first of all, we're going to apply with a lambda. So this lambda takes in all the variables that exist in the scope when it's called by reference, and then it takes the actual values contained inside the tuple as it comes to references. This is done once, and then we're using the same syntax that we saw previously, and it works in much the same way. This is repeated for every element of the for loop, so values takes the current value in this context. And then finally we just print the last closing brace once, and the second argument of standard apply is tuple that we're applying it to. So let's look at tuple concatenation. So tuple concatenation is pretty simple. It just takes any number of tuples, adds them all together, and creates a new tuple which contains all of the elements as if you just concatenated this together. Okay, and let's have a look at this. So on on line 12, we can see we have a function that returns a tuple. Now we're using the syntax, which I believe is C++ 17, so we could have used make tuple. So I'm talking about, of course, these here, and this will automatically recognise that it should be an integer and double, and return a tuple containing those two values. So we'll assign that. Now, what on earth is going on here on these two lines? So we want to create our two variables e11 and e12, and we want to, so that e12 is the second element of the tuple and e11 is the first element of the tuple. So what we can do is we can use the function standard tie, and standard tie is specifically for tuples, and it will take references to variables and assign it to a tuple. Then the values of e11 and e12 correspond to the first and second values of the tuple. And then in C++ 17 they also introduced the concept of structured bindings. So e21 and e22, well, they work exactly the same way, only that they automatically find the correct elements, and they automatically find the correct type for e21 and e22. So if we decide to run this, we'll see that it correctly prints out the same values for both methods of doing it. Now obviously it wasn't really necessary to use this, we could just use int and double, but it just makes it more generic. So if we were to change that int to something else, so let's do that. Let's change it to long, for example, and we'll recompile it. It does successfully print the same without having to change anything. So there are of course some other functions such as forward as tuple, and generally more specific use cases which I'm not going to go into here, but I think this covered most of it, so I hope this helped, and thank you for watching.